Hey everyone, in this AP Chem series video, we're going to take a look at how electrons are arranged in orbitals. So remember from the last video, we learned about the quantum mechanical model of the atom where there's energy levels or shells all made of various subshells or sublevels. Each of these subshells is then composed of regions of space known as orbitals, and those orbitals are simply areas where electrons are most likely to be found. This leaves one lingering question in my mind, and that is, what exactly is an orbital, and more importantly, what do they look like? So I think the best way to introduce orbitals and make sure we don't miss anything along the way is to introduce them with a table of 3 columns. The first column will list out each overall energy level, or what we call in this model the principal energy level. For each of those, we'll say exactly how many subshells exist in that energy level, and then for each subshell, what type of orbital exists there. So let's start the whole process by looking at energy level 1. This is the simplest one to start with because in energy level 1, there's only one type of subshell, and that one subshell is what we call a 1s orbital. So what exactly is a 1s orbital? Well, here's a diagram of what it might look like if you could see it. The x, y, z axis converge at a center point where you can imagine the nucleus might be. The surrounding blue sphere is the orbital itself. Technically, this is called a region of high electron density. What does that mean? Well, all that means is that if you're an electron and you're in the 1s orbital, you are most likely to be found somewhere within that sphere surrounding the nucleus. So that's the first energy level. Let's scale up to energy level 2. A little more complicated because there's 2 different subshells in energy level 2, and those 2 subshells are made up of the 2s orbital and the 2p orbitals. So let's start by taking a look at a 2s orbital so we can see what that might look like. Luckily, it's the exact same shape as the 1s. The only difference between a 1s and a 2s is that the 2s orbital is bigger, but it's still that same spherical shape. Next, we've got the 2p. Let's take a look at this orbital type. You might have noticed it's been pluralized because there's not just one single 2p orbital, there's actually 3 separate 2p orbitals. Here's a visualization of all 3. The blue dot at the center would be the nucleus, and these colored regions of space represent where the electrons would be. You'll notice the shapes get pretty bizarre. Again, you're just imagining that these purple, green, and orange regions are where electrons are most likely to be found. These 3 2p orbitals do have names, the 2px, the 2py, and the 2pz. If you put all 3 of them surrounding the nucleus at the same time, they look like this. Let's scale up now to the third energy level, the n equals 3. This, of course, has 3 different subshells, and you might be picking up on some patterns here. Those 3 subshells are the 3s, which is just like the 1s and the 2s, just bigger. The 3p orbitals, which are the same as the 2p orbitals, just bigger. The third type is our new one in the third energy level called the 3d orbitals. So there's only one s orbital in each energy level. 3 separate p orbitals following that pattern of odd numbers explains that there's 5 separate d orbitals. They're increasingly complex in shape and name. Here's what each one looks like. Each made of 4 distinct separate lobes, and at the center of each of those lobes is the nucleus. I'll say it one last time. These crazy looking shapes are simply regions of space where the electrons inside of them are most likely to be found. Here's a different version of those same 5 3D orbitals. Let's close out the video looking at the 4th energy level, although by now you should be able to predict most of what you'll see here. The 4th energy level has 4 different subshells, the 4s, the 4p orbitals, the 4d orbitals, and our new additional type is called the 4fs. These 4fs, there's 7 of those, and they're the most complex of all. Here's a nice visual of all 7 of the 4f orbitals. So this table is a nice way to summarize the energy levels, the subshells, and the orbitals that exist within each one. Good idea to pause the video, take a minute, write them down. That also wraps up this video on orbitals. Thanks for watching, and here is a brief summary.